Hello students, this is my second video on the chapter number system. If you recall, in the last lecture, the last video, I classified all the different kinds of numbers that you have studied and you will be studying in 9th standard in the form of flowchart and Venn diagrams. So in continuation to that, in this video I am going to deal with the definitions of the numbers. So the first definition I am going to deal is real numbers. As you can see, real numbers are the numbers that can be represented on a real number line. Any number that can be represented on number line is known as real numbers, right? So take an example of -1. Yes, I can plot it. 0, yes. 0.5, yes. If you talk about fractions, 2 by 3, yes, you have done this in previous classes. So all those numbers are real numbers. As you move forward, you will come to know that yes, we can represent irrational numbers such as √2, √3 will do in this class 9th only, right? Okay, so they are all real numbers because they can be represented on the real number line. The next terms that I'm going to define are rational numbers and irrational numbers. I'm going to deal with both these numbers together by the means of points of differences so that it is easier for me to understand. Now when I define rational number and irrational number, I take two modes of points of differences. I can differentiate them on the basis of fractions. I can also differentiate them on the basis of decimals. Now let's see the first definition on the basis of fractions. What are rational numbers? Rational numbers are the numbers that can be expressed in the form of p by q, where p and q are integers and q not equal to 0. I repeat again, rational numbers are the numbers which can be expressed in the form of p by q, where p and q are integers and q not equal to 0. Whereas if you talk of irrational numbers, are the numbers which cannot be expressed in the form of p by q, where p and q are integers and q not equal to 0. So this is one point of difference. So a number which cannot be written in fraction form is irrational number. Now second point of difference is decimal. On the basis of decimals, the decimal form of rational numbers can be of two kinds. The decimal form of rational numbers can be of two kinds. One, terminating, which terminates after some digits after decimal. For example, 0.73 terminates after 3. 2.467, it terminates at 7, so it does not move forward. So these are the kinds of decimal expansion which come under rational numbers. The other form of decimal expansion can also be included in rational number is non-terminating but repeating. In some textbooks they use terms like non-terminating but recurring. So all these terms mean the same. Non-terminating but repeating. Example 1.3737 and so on. Sometimes we represent this as 1.37 bar also, right? So these kind of numbers are also rational numbers. So rational numbers can be of two kinds. Terminating, the decimal expansions of rational numbers can be either terminating or non-terminating but repeating. On the other hand, if you talk of irrational numbers can have only one form of decimal expansion. What is that? The decimal expansion of irrational number is of the form non-terminating and non-repeating. In simple words, neither it terminates nor it repeats. Examples are √2, √3, root of all prime numbers for that matter are irrational numbers, definitely. And numbers like 1.23, 233, 2333, 2 ... Now if you look at here, this is because of ... this makes sure that it is non-terminating right? And is it repeating or not? Let's see. Is this one digit 2 is repeating? After 2 we have 3, so 2 is not repeating. Let's take 2 digit 2 and 3. Is 2 and 3 repeating? First is 2 and 3, the next digit is also 2 and 3, the next is 3 2, so it is not repeating. Shall we take first 3 digits? 2 3 2, is it repeating? No, I don't find again 2 3 2. If we take 4 digits, again it's not repeating. So this makes sure this pattern attached. This is known as pattern. That means I can, by attaching such kind of patterns to any number, I can make them a rational number. I would like to take you to a separate sheet because this can be asked as a question. Find out irrational number or create an irrational number between given two real numbers. So just to help you, see how can we make our own irrational numbers. Suppose I consider I have to find irrational number between 1/2 and 2/3. Fine, these are real numbers. I have to find rational numbers between 1/2 and 2/3. What shall I do? Now what I'll do is, first thing, I will convert them into decimal. So I convert 1/2 can be written as 0.5, and this is step 1. Convert them into decimals, and this can be written as approximately 6.6 ... So can you now find a rational number between them? Very easily. A rational number between them can be 0.51, right? This is between 0.50 and 0.66. So, but the question is not finding a rational number, the question is to find an irrational number. So what I do is I attach a pattern to this number. Now let's see how to make a pattern. You can use any 2 digits. Suppose I use 1. After 1 I put 0. The next number can be 1 again, then 2 zeros, then 1, then 3 zeros, 1, and so on. This goes on. Now what I have made sure that this decimal expansion is non-terminating because of this ... and it is not repeating because of this pattern. So in short, I have made or created an irrational number which lies between 0.5 and 0.66 bar. That is, this is the number. This is step 2, attaching a pattern. So I got a number, irrational number between 1/2 and 2/3. I hope it is clear. Now you can find a number between any two numbers, rational or irrational. Any number. Rational you have studied in early classes, but in 9th standard I am teaching you how to find irrational numbers between any two real numbers. So if you ask me to find out rational numbers, then very simple example was, take 0.51, 0.52. Now converting to decimal is always a very easy way rather than making them fraction. And you remember in early classes you used to do taking LCM, multiply by 10, numerator and denominator same that the other fraction, and then find the numbers. But once you are aware, once you study decimals, and it is the easiest way, so we prefer decimal. Fine, so I convert the end points. First step 1 is to convert the end points into decimal. Step 2, in decimal find the number. If it is rational number, then very easily. If it is irrational, even easier. You can just attach a pattern to these numbers and then it becomes an irrational number, right? Well, so now let us continue with our previous notes. So I differentiated rational and irrational. Then after that, all those numbers which are left out are, you've already studied about it, like integers. Integers is collection of 0, 1, 2, 3 and so on, minus 2, minus 3 and so on this side. Whereas a whole number is collection of 0, 1, 2, 3 and so on. Natural number, which is represented by n, is collection of 1, 2, 3, 4 and so on. One more thing that I would like to discuss, this is, since rational number can be written in two forms, rational and decimal, fraction and decimal. Yeah, since rationals be written in two forms, one is fraction, the other is decimal. So do you agree that they should be interconvertible? Right, now let us see, because they are representing the same number, so they should be interconvertible. Let's see which all conversions we know. Can you convert first? Can you convert from fraction to decimal? Yes, very simple, because you give me any fraction, so say for example 2 by 5. This is a fraction. Can you convert in decimal? Yes, I simply divide 2 by 5, so I get 0.4, it's 20, so the answer is 0.4. So I converted a fraction to a decimal. This is terminating. I can take an example of non-terminating also. 1 divided by 3, I get 0.33 and so on. So this is 0.3 bar, which is again a decimal expansion. So I come to know that converting from fraction to decimal we have already done. Let us check the other conversion from decimal to fraction. Now decimal to fraction, let's see, suppose I have a decimal number like 0.24. I can very easily convert it. We all know that conversion is very simple. This is equal to 0.24 can be written as 24 by 100, which you can simplify further to get a fraction. 6 by 25. This is a fraction, so I converted a decimal into fraction. Let's check the other form of decimal expansion, because we know there are two decimal expansions. Which are the two decimal expansion? It can be either terminating or non-terminating but repeating. So next example is, this is example of terminating. Next example is non-terminating but repeating. Now this is important because generally you get question on this. Say for example, converting 2.37 bar. The bar is on 7. That means you have to convert 2.3777 into fraction. Now if I follow the same method which I used in the previous kind, then I would write this is equal to 2 point decimal. If I remove decimal, it will be 777 and so on, and divided by 100, 0, 0. How many zeros should I put? I'm not sure. So this method is wrong. I can't solve this question, or I can't convert this into fraction by the previous method. So I have to get another method, right? So the other method is, for the method to solve this, I'll tell you. Just pay. So the question is, convert 2.37 bar in PYQ form, right? So what I do is, first I consider this to be x. Say let x is equal to this. Now I see step 1 is I have to observe after decimal, do I have all the repeating digits, or do I have a non-repeating digit also, or any non-repeating digit? Yes, if I see this is 3, which is not repeating, only 7 is repeating. If I have one non-repeating digit, I multiply both the side by 10. If I have two non-repeating digits, say for example if I were to have 3, 7, 8 bar, say for example, then I have two non-repeating digits, so I multiply by 100 both the sides. In this case I have one non-repeating digit, so multiply by both the sides, so I get 10x is equal to 23.7 bar. This be equation 1, right? Now what's the next step? Now I have, after decimal, I have only repeating digits, so I number this as equation 1. What to do next? I take number this is as equation 1. Under the repeating set of digits I have only one. Now under the bar I have only one digit which is repeating. Another example, suppose you have 2.378. This is under the set of repeating digits I have two digits. In this case I have only one digit. So now since it is only one digit, now I multiply both the sides of this equation by 10. It becomes 100x is equal to 237.7 bar. Let this be equation number 2. The next step is, and after that it is always same, that will be equation number 2, then always equation 2 minus equation 1. So 100x minus 10x is equal to 273.7 bar minus 23.7 bar. What am I getting? Decimal. This becomes 90x, so x is equal to 214 by, and you can further simplify this to get so now what I have done, I have converted x which was in decimal to fraction. Hope this is clear to you. Fine. In my lesson plan I have given some homework also, you can download those. These questions I would like you to do it. I would request you to copy down all these notes, complete in your class notes, mathematics class notes, and please do these questions in your home assignment copy. Try these questions in your home assignment copy. Thank you.